So far we have seen that there are a lot of different types of pipes in terms of steel grades and connections. Based on such wide range, the operators must select the most appropriate combination of products to withstand their well conditions. This stage is known as string design. String design implies selecting the best combination of pipes and connections to satisfy the well requirements during its entire life cycle. The string design involves three steps. First, the mechanical design. Second, the material selection. And third, the connection selection. But what do you understand by mechanical design? This design serves to identify the appropriate yield strength and the thickness of the pipes for each particular OD. This analysis used to be performed manually and only considering the stresses in one isolated direction. That could be axial, that is tension and compression, or transversal, which is burst or internal pressure, and collapse or external pressure. The mechanical design has evolved, and today it considers stresses in three combined axes: axial, transversal, and circumferential, known as von Mises. This design involves the use of complex formulas that can be easily solved through different software available in the industry. Input information is required to fit this software. This data includes some general information about the customer and the location, and specific information related to the characteristics and the type of the well, including composition of the produced fluids, pressure, temperature, as well as other parameters if they are available. Additionally, the purpose and depth of each string to be designed must be specified. Remember when we saw OCTG products? We had said that the string design will be specific for each particular use of the pipe. It is completely different to design, for instance, a 5.5 string if it will be used as production casing or drilling liner or tubing. The loads to which such string will be subjected will depend on their use, and as a consequence, their design factor will be different. Okay, once the information is entered into the system, the designer must define different load cases which represent events that the designed strings would eventually face during their lives inside the well. For this operation, the well conditions must be analyzed in deep detail to determine the proper load cases that better describe such situations. The output of this process is a graph with the service envelope of the selected pipes and the stresses produced by the different loads considered in the design. Additional to the graph, the design factors calculated for each of the 5 design parameters: burst, collapse, tension, compression, and von Mises are indicated. Those design factors must be either higher than the ones considered as a standard by the oil and gas industry, or higher than the design criteria established by the operators. If any design factor doesn't comply with this rule, a different pipe, that is, a different grade or weight, must be considered for the same outside diameter, and this process must be reformulated. To wrap up, with the mechanical design, we have selected the best pipe to mechanically withstand the loads in the well.